So I'm going to talk Phantom Plus and the Hex Motion platform at Montefiore in the Bronx. But first, I do have a couple of disclosures. So firstly, I have received an honorarium for this webinar presentation. And the second disclosure is that any views that I present here are mine solely. They do not represent Montefiore Medical Center, or nor do they represent Accuray, the makers of the Radixact device. So today I'm going to talk about a few things. I'm going to go over the device specifications of the Delta 4 and the Hexamotion platform. Next, I'm going to talk about the Hexamotion file requirements and how to generate those. Then I'm going to go over the actual device setup and IMRT QA measurement. And finally, how we use the system as a whole to help validate motion correction with the Radixact Synchrony system. So for anyone not familiar with the Delta 4 Phantom Plus, this is an image showing the device. On the right-hand side, the gray region, you can see the cylindrical region that houses the detector arrays with the measurement area bounded by those two black lines. And on the left of the screen is the white plastic housing that contains the device electronics, the battery, etc. So the Delta 4 Phantom Plus is a 22 centimeter diameter cylinder with a 40 centimeter length. It's available in a couple of different configurations, either with just a standard PMMA plastic or the plastic water DT, which is Scandidos's water equivalent plastic, tissue equivalent plastic, sorry. It has horizontal and vertical p-doped silicon diode detector arrays, each with a 20 by 20 cm squared area. There is a 0.5 cm detector spacing in the central region, which is the central 6 centimeters, and there's a 1 centimeter spacing in the outer region. It is also possible using the software to measure larger fields using 2 consecutive measurements and shifting the chamber. And also it is possible to measure with a finer resolution in the center, again by shifting the detector and performing 2 consecutive measurements to give a 2.5 millimeter spacing in the central region. It also has available ion and chamber inserts for all common cylindrical ion chambers that allow you to take a verification measurement using an ion chamber as well. So this is another graphic of the Delta 4 Phantom Plus, and you can see the detector arrays represented by the green dots with each detector showing the spacing of those different detectors. And on the front, on the left-hand side, you can see on the top left, you can see the cylindrical insert, and you can also see the mounting bracket for the Hexamotion platform, one of the mounting brackets for the Hexamotion at the front there. The Delta 4 Phantom Plus also has an Accuray or tomotherapy configuration, and this has the addition of a removable section designed to allow the placement of the Accuray ball cube phantom, shown on the bottom left. This precision machined insert allows you to have either the plastic or to place different targets, so for use of tracking using the Synchrony system. At Montefiore, we also utilize 3D printing to create various cube inserts with a range of different fiducial configurations, and also some dense silicon plugs of different sizes and shapes to really test the Radixact Synchrony's fiducial tracking and target detection capabilities. So here I have 3 images showing the pieces removed on the left-hand side. In the center, you can see just the central cube phantom, and that is where you would place the Accuray ball cube phantom or any other tracking target. And on the right, you can see the fully assembled. Next, I'm going to talk about the Hexamotion platform shown here, and this is the image showing the Hexamotion with the Delta 4 mounted. I have some images later on showing the Hexamotion on its own without the Delta 4. Next, we have the specifications of the device. So as you can see, it has an 8 centimeter range of motion in each direction, much greater than any motion we see in radiation oncology. It also has the capability to adjust both the pitch and the roll at setup, and also during delivery as well. They can be adjusted so that you can have motion delivery files that include rolls and pitches to have complex target motions. It has 50 Hertz refresh rate, so it's very quick in terms of changing its position, and it also has a better than 0.5 millimeter positional accuracy as well. It has very quick positioning speed, so it moves from position to position very quickly, very smoothly, and we haven't had any issues with it at all. It's all the motion files that we've tried to test it with, it's been capable of delivering, with the exception of some 2.5 centimeter, plus or minus 2.5 centimeter motions, which were moving very fast. The motion file generation I'm just going to talk about briefly. The Hex Motion uses very simple scripting and tab separated variable files to move from position to position. So you can create these motion files with Microsoft Excel for simple files if you're trying to generate sinusoidal motions and things, or you can use simple scripting to also generate various motion files. You can also, it is possible to take realistic patient data. We took some data from the Calypso system and converted that into motions to represent actual measured patient motions as well. So the tab separated variable file has either 3 or 5 columns required. The first 3 columns are the absolute position in the XYZ coordinates relative to the origin at each timestamp. And the 4th and 5th columns are optional, and they represent the roll and the pitch respectively. As I said, if you do have any motions that are beyond the capability of the system, when you try to open the motion file, it's going to have a little pop-up window saying that, giving you a warning and asking if you want to smooth the motion file. And then you can use the software to smooth the file so that it is capable of being delivered with the Hexamotion platform. So I see you should see on the screen now an example motion file. This is just a quick 60-second file, but the software is capable of handling much longer motion files. I just wanted to clearly show an excerpt here. I think the longest motion file that we've loaded to the software was approximately 30 minutes, and it didn't have any issues with that at all. If you are using simple motion files, such as sinusoidal files, the software is capable of looping the files as well. So you don't have to have very long files if you're just doing a sinusoidal motion. The only caveat to that is that the start and the end position needs to be a similar position for it to be able to quickly move between the two. You don't want to have, as this motion file has a large disconnect in here in the y-axis, sorry, going to 0 at the start, the software will have issues when it comes to trying to do that motion. The other thing is that to note is these motions are relative to the origin determined by the user. So once you set up the device, it has a nice remote control that you can use to shift the phantom. And then once you apply any shifts or any setup positioning changes, when you go back to the software, it's going to say the phantom has moved. Do you want to use this position as your new origin moving forward? And on the right here, you can see this is an excerpt from this motion file. So you can see it's very simple file generation that's required. Okay, so now I'm going to talk about my personal experience with the device. At Montefiore, we installed the Radixact Synchrony in the autumn of 2019. And as part of the validation of that system, I've delivered over 200 IMRT QAs, with the vast majority, 99% of them being mounted on the Hex Motion platform, and both with and without motion correction. So the vast majority of those 200 plus patients had motion, and we were investigating the Synchrony's ability to correct for that motion. All of my experience to date has been using the Accuray precision treatment planning system, but I'm sure it's very simple with any treatment planning system to generate your dose distributions and export them to the Delta 4 software. So we generate IMRT QA plans in the Accuray TPS. We calculate on our own CT scans of the phantom with different inserts in that cube section that are tracking targets. You then export just simply the plan dose file to a shared drive location. It is also possible to export the contour file, and the software can show contours if you're interested in seeing those on your actual IMRT QA delivery. So now I just have a couple of slides showing once you try to import in the software, Here you can see it's a very straightforward process. It just searches the shared drive. You can have various filters by patient name and date and etc. And once imported, then it's again very straightforward to open the patients. You can search by a range of criteria, but very, very quick to open the files once exported. And here's an overview of the software. So on the left, you'll see a large list of IMRT QA plans that I delivered. In the center, you can see the plan device setup. So it's a very nice software. It has everything is kind of to hand, and it's very fast. It doesn't have any issues with loading patient plans. So I think, for example, for this one patient, one of my test patients had 60, 70 deliveries in it, and it didn't have any issues loading these large patients. So now I'm going to give a brief overview of the actual setup. So the Delta 4 is nice in that it's battery powered and it has a very long battery life. So it connects wirelessly to the external workstation. We just have a router in the vault. So it's no wires on the Delta 4 itself if you're just using the Delta 4. The Hexamotion just uses an Ethernet cable and a power cable to connect to this same router as the Delta 4, so it's very straightforward setup. If you're not using the Hexamotion platform, the Delta 4 can be leveled with, it has either a 3 feet or a 4 feet configuration, and they can be tightened to ensure reproducibility. You don't have to keep changing the setup position. And the ScannerDose cart is also very nice in that it allows the Delta 4 to be placed very easily on the couch without any lifting. You can just use it to slide the Phantom onto the couch. And next is just a quick highlighted view of the bottom left of the software screen. So here you can see it asks for a temperature correction, and you can select some different positioning preferences of the device as well. For example, if you wanted to reverse the device and have the electronics at the head of the couch, you can do that, and various gantry orientations. So here's two images of our actual Delta 4 in the cart that we have. The cart is available in a couple of configurations as well. We just have the one that can hold the Delta 4, not the Hexamotion platform, but I do have some images of that later on. So it's a very ergonomical design. As you can see, it has this cutout section that allows you to stand close to the device when sliding it onto the table. So there's really minimal lifting involved, and the feet also are a soft felt, so there's not going to scratch the couch top or anything like that. So it is very straightforward in terms of setup. And then all you do is, once the device is turned on, it will connect to the software outside. Next, talking about the Hexamotion setup. So we do not, as I said, we do not have the trolley that allows the Delta 4 to remain mounted on the Hexamotion. So once homing the Hexamotion, we then place the Delta 4 on the platform. It attaches using the slotted connector on the front, which I showed earlier, and there's two ball and socket joints on the rear of the device. It is possible to mount the device with just one person, but it is much easier if there are two people. So it's always nice if you can get some help. And once mounted, the Delta 4 is easily positioned with a remote control. You can adjust its X, Y, Z coordinates. You can adjust the pitch, the roll, and it's very straightforward. You then set up the device once it's on the Hexamotion platform. And I do have some pictures of the cart coming up. So here is the Hexamotion itself. So on the left, you can see the Hexamotion on its own without the Delta 4, and on the right you can see the Delta 4 mounted. So as I said, on the right hand side here, you can see that this is the two connection posts for the rear of the Phantom. This is the controlling electronics, and this is the front mount, which goes into the front of the Delta 4 to then hold the front end stable. And then the front mount goes on this sliding smooth metal tray to allow for the motions to roll back and forth when the Phantom's moving without doing any damage to the couch, which is very nice. One thing to do note, this cable is a little short, so we actually add an extension cable just to make positioning this a little bit easier. And here are some images of the Hex Motion Trolley with a true beam. So you can see here, this allows the Delta IV to stay mounted on the Hexamotion, which is, again, means that you can place it easily with just one person. It just goes over the couch and you can place it directly onto the treatment couch. So there are nice ergonomical options, which unfortunately we just don't have at Montefiore. So next up, I'm going to show example dose measurement. So here you can see a measured dose distribution. I have a few more examples later on showing with and without motion correction. But this is the delivery with the motion correction enabled for a PTV, which is split into a superior and an inferior section. You can see these high dose distributions with a small gap in the middle. So on the left-hand side of the screen, you see the list of all the different deliveries that were delivered. It's very straightforward to select by right-clicking on the measured dose distribution. You can select what you want to compare to. So whether that be the planned dose distribution or another measured dose distribution, as we were doing with this case, it's very easy to compare between the two. On the bottom left, you see the device setup, just to verify that. And then at the bottom of the screen, you can see various statistics. So on the left here, we have the percent dose deviation. In the middle is the DTA criteria, and on the right is the gamma index. So I'll go into each of those later as well. And on the top right here, you can see a color wash. You can change your dose of interest. You can use between absolute dose, relative dose. You can display the gamma index and things like that. And then below here, you can see the structures. So if you do export the RT structure file, you can overlay structures of whichever structures you're interested in. So as well as the view I just showed you, you can also use a 2D view. Again, you can easily add isodose levels of interest that you want to take a look at, or structures. So it's very nice software, very straightforward to use, that you can just pull up all the information you want. This is a 3D view showing the detector position spacing and just giving you a little bit more information. And again, you can also change any of these views to be relative dose, absolute dose, or the gamma criteria. And finally, one of my favorite actual features is if you right-click on any of these measured comparisons beam statistics on the bottom here, it's possible to look at a gamma table. So instead of having to recalculate with different gamma criteria, the software automatically calculates everything. So you can really just take a look and see where the delivered IMRT QA is failing. So here you can see that this was a very, very good QA, only failing with the 0.5 millimeter 0.5% criteria. But these tables are very nice for quick analysis of the actual measured IMRT QA. And these are exportable as well. So you can export these to Excel if you want to maintain a record of everything. I think you can print them into a report as well. Okay, so now I'm going to talk about some of the Radixact Synchrony testing that we did. So just a brief overview of that testing. So we measured IMRT QA for various treatment plans and motion pattern configurations using the Delta IV. We also used film and a couple of other detectors as well, just to really validate the system. These results were presented at the AAPM 2020 annual meeting under the title The Initial Evaluation of the Radixact Synchrony System by myself et al. So measurements included the phantom in a static configuration with no motion compensation, the static phantom with motion compensation enabled. This was to account for any additional KV imaging dose. So the silicon diode detectors are sensitive to low energy radiation in the KV range. So we had to take measurements including that imaging dose. And then we had a moving phantom with no motion compensation and a moving phantom with motion compensation. So as I mentioned before, the resolution in the central region is 5 millimeters, although it's possible to have a 2.5 millimeter resolution. Instead of doing that, we placed film in the quadrant cutout to allow for high spatial accuracy measurements. So this is some of the results of this publication. So you can see on the left, this is all measured with the delta 4. These are various sinusoidal simple motions in the Y direction and the XZ directions. So the Synchrony system has both a jaw motion and an MLC offset that is used to compensate for target motion. So we separated these out to kind of see the effects of each of them. So as you can see in the uncorrected columns, as the motion increases, the measured gamma criteria gets worse and more points failing as expected. And then you can see when we turn the motion compensation on, the IMRT QAs again are almost 100% passing, and this is with a 2% 2mm criteria. This table on the left is with the respiratory tracking, and the table on the right is with the fiducial tracking. So both of these methods show very good motion compensation. The next tables down, this is the XZ corrections. So again, not as large an effect on the dose distribution with these motions because of the helical nature of the delivery, but still we can see when the Synchrony corrections are applied, it gets much better dose distribution. The bottom table is more complex motions, including Y and XZ motions with different periods. So again, very, very good. So this is some of this data shown on the delta 4. So this is a plus minus 1 cm in the Y direction only with no motion compensation, and here you can see, the QA is failing in pretty much all criteria. The percent dose difference is high, the distance to agreement is high, and the gamma criteria looks a little all over the place. And then it's very nice that you can see by turning on the gamma view, you can see these bands of high and low dose, which is what you expect with this sinusoidal motion in the Y plane. Some of the areas of the PTV were getting much higher dose when this overlaps, and some are getting much lower dose. Now this is the same plan delivered with the motion compensation turned on, and now you can see, we have 100% of points passing our gamma index. And if we look at the gamma index, the vast majority, all the points are less than 1. So the motion compensation is very good in the Y direction because the jaw on the Radixact Synchrony has, very fine resolution when it's moving with the target. So that's my end of my presentation for today. In summary, we did have a couple of very minor teething issues when learning the software, and one issue with the Hex Motion platform, which was corrected simply by updating the software. Scandido support are always quick to answer any questions and help with any issues, whether it simply just be user error or any minor issues with the device themselves. The Delta 4 Phantom Plus is found to be very reliable for the past year, easy to set up, allows for accurate, easy analysis of the dose delivery, and has a lot of nice features. The Hex Motion platform was very good. It allowed for accurate, quick positioning of the Phantom itself in 3 dimensions, with the roll and pitch as well. And the combination of the two was really critical for allowing the validation of the Radixact Synchrony system. As I said, we did do some measurements with a 1D platform and film and things like that, but each of those had their own issues. The film is always tricky to work with. So the Delta 4 Phantom Plus, in combination with the Hex Motion, was great. It was really our workhorse for the validation of the system. So that's the end of my presentation. So again, I'd like to thank everyone at Montefiore who helped work with me on these measurements, and thank Anders again and Scandidos for their support and the opportunity to present to you all today. So if anyone has any questions, I am happy to answer them.
Thank you very much, Lee, for this presentation. As mentioned, please feel free to ask any questions. I have, let's see, the first question here is, which information can you get from using the Delta 4 together with a Hexamotion that you couldn't get with the other systems?
So the only other system that we have is a 1D motion platform. So that's very limited in terms of being able to separate out the motions. Because of the motion itself, that is always going to be a combination of the Y motion and the XZ motion on the just the Y motion and the X plane on the Radixact Synchrony. So having the Hex Motion platform with its full 3D motion is obviously the most realistic to the actual patient target motion, and also allowed us to separate the motions out to see the different compensation as well as them combined. So it was great, and we also we took part in the AAPM Match Grand Challenge. So that utilized the Hex Motion platform as well, with a platform to place a target and really check the KV imaging target detection of the system. So that was that allowed us to test that as well, which gave us confidence in the system that it is capable of detecting these different lung lesions and fiducials, and then also that the delivery is a drastic improvement in the dose delivery versus no motion compensation.
Okay, thank you very much. And another question here, sorry. How long is the setup time for the measurements? I guess with the combination Hexamotion Phantom Plus.
So with the Delta 4 itself, as I said, everything is wireless. So it's simply a case of positioning the Phantom on the couch as you would. You just slide it off the trolley and you set up to your lasers, turn it on, and then when the time you're outside and the door's closed, you can open the software, and it's very, very quick. So only a couple of minutes really to set everything up. If you don't have the Hexamotion and you're using the 3 or 4 feet configuration, once you have the device level, you can tighten the bolts so that the feet aren't going to shift, so that you're not having to level the device each time. So other than very fine adjustments occasionally, again, that locks into place so that you're not adjusting the level a lot. So again, very quick. With the Hexamotion platform, as I said, we don't have the trolley that allowed it to remain mounted. So once the Hexamotion was placed on the table and homed using the remote, again, then the Delta 4 you could lift it onto the Hexamotion platform, connect the 2 rear pivots, and connect the front mount, and then it's ready to go. The Hexamotion connects just using an Ethernet cable to the router. It has to be the same router that you use for the Delta 4. So we just had the router mounted on the wall of the vault. The cable went to the Hexamotion, and then once it was plugged in, again, a very quick setup. And then you can use the remote again to fine position the device itself and adjust the pitch and roll, make sure everything's level before you CT the Phantom. So again, only a few minutes for each one.
Okay, thank you very much. Another question here. I don't believe you mentioned it. When are you going to start to treat patients, and how do you plan to do your patient QA then?
Yeah, so as I said, we installed the system in the autumn, like September, October of 2019. We were the second Synchrony system in the world that was installed for clinical use. So we really wanted to make sure, even though the device is 510(k) cleared, we wanted to make sure that it is working very well before we treat patients. So it took us a few months to gain that confidence in the system. And then by February or March, when we were ready to treat patients, unfortunately, the world changed, as you're all aware. COVID hit, and then unfortunately, New York at that time was hit pretty hard. So we stopped pretty much treating patients in the particular facility where the Radixact Synchrony is. We were very focused on the hospital as a whole was treating COVID patients. So unfortunately, that got delayed. So at the moment, things have obviously gotten much better, thankfully. So now we are in the process of identifying patients, and we plan to treat as soon as possible, hopefully in the upcoming weeks. Okay. So as to the role of the Delta 4 in the actual patient QA, so our plan is to, at least for our initial patients, to take 4D motion studies of the targets before we do any treatments. We plan to use those simple motions measured at the 4D CT, try to replicate those and measure those before the first treatment. And then the plan is for our initial patients, we're going to take the measured motion files from the actual delivery itself, because it is possible to extract that from the Radixact Synchrony to take the measured motion of the delivery, and then we're going to put that back onto the plan and deliver between the first and second fraction just as another validation.
Okay, thank you. One final question here. I'm going to read. Thank you for a very nice presentation. It's very impressive to see how well the Synchrony system can do. So, to speak, restore gamma index when the compensation. Sorry. Which parameters do you look at when doing the validation of the Radixact system?
So there are a few different things that we looked at. Firstly, as I said, we were very new to the system, so we tried a lot of different fiducial configurations to kind of test where the system failed. We also looked at different density plugs and different size density plugs because the system is capable of detecting lung lesions without any fiducials. So we wanted to really see where the system failed before we went to the stage of patient selection. We also then used some software to validate that the measured motion that the Synchrony was measuring motion that matched that delivered motion file that was given to the Hex 4. And then finally, the dose distribution is the final say that this is much better than you get almost perfectly to the planned dose distribution when with these different motion files being delivered. So we got really confident in the system. Personally, it was even when taking very small lesions, it was able to pick it up. Things that I couldn't see visually, the software was able to detect. So I gained confidence in the system that it works as Accuray say. So I'm very happy with the system, and hopefully we can start treating patients as soon as possible.
Thank you very much, everyone, for listening, and thanks to you, Lee, for presenting. It's been a pleasure listening to you. And you all please take the opportunity to visit our website where you can find more useful information about our QA solutions.